Okay, so we've got another example to do with the constant acceleration formula. A particle is moving in a straight line, constant deceleration 4 meters per second squared. At time t equals 0, the particle passes through point O with speed 13 meters per second towards point A, where O to A is 20 meters. We're going to find the times when the particle passes through A and the value of t when the particle returns to O. So it seems strange that it should be times. The idea is that it's going to be 2 times rather than just going through A once. Because what's going to happen is it's going to go towards A because it's decelerating, it'll pass A and then come back that way. And we'll see how it actually works when we look at the equations. So, to start with then, we've got deceleration is 4 meters per second. So therefore, the acceleration is minus 4 meters per second squared. The initial velocity is when we're at O, so it's 13 meters per second. O to A is 20 meters, so that's what S is. And we are trying to find what T is. So T is the question mark. So the equation that connects the four of those is S equals UT add a half AT squared. And we can substitute everything in. So we've got S is 20 meters, we've got U is 13 meters per second, A is minus 4, so half times minus 4 is minus 2t squared. So really it's a quadratic equation, and that's why we end up with two solutions. So that's really 2t squared, take 13t, add 20 is equal to 0. And then we just want to solve that by any method that we like. So possibly factorising, I don't know if it will or not, or maybe just using the calculators. Okay, so however you choose to solve it, you end up with two solutions. One is t equals 4, and the other is 2.5. So those are the answers to the question. Okay, now part B, we want the value of t when the particle returns to O. So we've got the initial velocity and deceleration there staying the same. What was the deceleration? Minus 4. So acceleration is minus 4 meters per second squared there. We're trying to find t. The other thing we actually know is that when it returns to O, the displacement is 0. Remember, S is displacement, not distance, because obviously the distance is not going to be 0 because it's gone somewhere and come back. So the displacement is 0 because you're back at the start. So it's using the same formula, in fact, S equals UT at a half AT squared. So 0 is equal to 13t, take 2t squared, and we can very easily factorise this one to get t, 13 take 2, t. And so the solutions are t is 0 or t equals 6.5 seconds. So that one is at the start. So the answer to the question is that we will return to O after 6.5 seconds.